So now let's change this a little bit. We said that we could have anything in the numerator. Well, what if we had, oops, x minus a? If we have the same thing over the same thing, it's just going to be 1. But what if it was then x minus b, not sub b, sorry, minus b. And so, oh, I want to show you this idea because right now we can plug in these numbers. So look at what's on, and I'll write it back in red. So we have this y equals x times x, really, because if a and b are both 0, all divided by x. And so what I want you to see is, even if there's something in the denominator, the graph doesn't always look like the two that we just pictured, right? So this is really where a lot of kind of analysis or thinking comes in. Well, we can see here, and what I hope that you automatically start to recognize is we can have, right, x divided by x. These two divide to 1, and then we can simplify that, and that will look like, right, the line, I'll do y equals x. However, what I want you to see, while this is what the graph looks like, right, this line, y equals x, because it started off with x in the denominator, we need to clarify, put the stipulation that x cannot be 0, because even though we simplified it a little bit, this was still this original function with this x in the denominator, and therefore, right, not x equals, x cannot be 0, right? We have to kind of clarify that in this simplified version of this rational function. And where we see that in the graph is, I'm pointing, look at the points. What's going to happen when I get to 0? It says, right, undefined. Sorry if I can hold it there. It doesn't like to hold. You have to like hold it down, right? It says that my 0 here is undefined. And so this, right, what we just saw before, we talked about the different types of discontinuity. Before we saw these vertical asymptotes. Now this is called point discontinuity or a hole, right? We can see the hole in this graph. If I can, here, maybe if I can hold it down with my one hand. Let me change my color. So right here, this is called a hole, or not a point of discontinuity, but just point discontinuity, because it's only discontinuous. Oh, I can't spell this. Discontinuity. There we go. Right. So because it's only discontinuous at this one point, otherwise the whole rest, right, this is all clear, this is all clear, right, it's just an exact line. The only way we see this hole in the graph, or this point of discontinuity, this point discontinuity, is because of this denominator. And why it's not an asymptote is because the x divided by x kind of factored out. And so we're going to see that in this idea of, even if we, so here, obviously, we kind of simplified it just to have all of the zeros. Sorry, if I take my finger off the pad, it takes that away. So we'll take that away for now. And clean that up a little bit. All right, so we have this hole or point discontinuity at x equals 0. And so we can see, and actually, let's see if I can delete that one. I'm just trying to, if we look in our, here, we have x minus a on the left. So I'm going to divide that x out, because we're going to see that while this, well, we'll leave b at 0, so the line won't change, but we're going to see where this point discontinuity, this hole, moves, because it's not going to be at 0 if we change, right, a to not be 0. So if a is, Let's go all the way to 4. So let's see what happens now at x equals 4. Right? Because it's x minus a. So I'm going to rewrite that. So let me go back here, put this back to 0, clear all of this. And now let's move to 4. So now we've created, right, I'll plug it all in, y equals x minus 4 times x, because b is still 0 down here, divided by x minus 4. So again, we see this same factor, x minus 4, x minus 4. So we want to simplify that, right? We want to divide those out, and we get the line y equals x, right? Our line did not change. But if you notice, because that x minus 4 was in the original denominator, right here, right? Oops, I'm changing my color. We have to write x cannot equal positive 4 because of this x minus 4 in that denominator in that original function. So we see again, because x minus 4 divided by x minus 4 factors and divides out. I know you want to say cancel out, but that is not a mathematical operation. So I'm not going to say that, right? Factors and divides out, right? We have a whole at x equals 4. And so this is again why we talk about these places just as the x value, because technically, right, there's not a y value. It's undefined. So we can't really write it as a point. We just use the x value. So we have this whole. So we have these different types of discontinuity depending on how we can algebraically manipulate these rational functions. All right, and